Um, I think I'm audible. Yeah. Sharing my screen. Today, today let's talk about let's see. In my previous stream, we have seen about um, a ranking algorithm where you get search results and you rank them based on the relevancy of the documents, like which means that the search results basically. So we'll see why TF-IDF term frequency inverse document frequency are not enough, and what is the better algorithm or better ranking function that currently search engines uses. I'm sharing my screen. Um, this template is basically used for mathematical proofs, doing any DSA questions, CP problems. So yeah, we can use the same template. So the first question is why term frequency and inverse document frequency alone not enough. So think about this case, right? So where you have one document, document A, has, why is it already suggesting? It's still, if you put enter, it goes. Okay. Okay. Doc A has, let's say frequency of 2 as 2 words of length, say x. Doc B has, no, doc A has word, okay. No, assume that doc A has word appearing 4 times. Doc A has word appearing 4 times of document length x, not normal length. Of document length x. And document B has 100 words of, has words appearing 100 times of document length, maybe 10 maybe 10x. So what I mean to say is, so you have a document A with a word appearing 10 maybe 4 times, and you have document B with appearing 100 times, but it's like bigger length. So there is more probability or more chance that if a document of more length containing a word more repetitively, that means that the document is more focusing around that word. Like maybe if you have a paragraph or something which describes about a digestive system, the more probably you will have word called as intestine or gut, something like that, because that's what it relates around, and it does like that. But the thing is, this cannot be always your answer, because this is normal to it, normal to this document, but this is not normal to this document, right? Because A is appearing very less number of times of length x, but with a bigger length document, word B, the same word is appearing more number of times. So there is no penalty of TF-IDF fails here, because TF-IDF, let me put multiplication symbol so that you can, TF-IDF fails here because of linearity, no frequency saturation. So what I mean to say is, here length of the document also matter and the frequency also matter. It's not guaranteed that more frequently the word appears, the more relevant the chunk is, because yeah, like that's a fact, right? So if you are reading some book about digestive system, there is a more probability or chance that the book has a word intestine or gut in that 100 length document, But if there is a sentence with two three lines, if there is a document with two three lines and that contains a word gut two times, maybe that's a good for that's a good search result for user, because yeah, like that's important information, right? Like, but here you can ask, but can I scale down the document like this? So you're comparing x and 10x, and here if you're comparing 4 and 100, if you make this x and if you make it 10 at the same length, a word is appearing 10 times, which was appearing four times earlier. So this is not a good thing, right? Because intuitionally it doesn't add anything to the user, and yeah, it's not a good search experience. So a new algorithm came called as BM25. Sorry, my bad. BM25. So its full form is best match 25. What it does is, along with TF-IDF, it does two things. Along with TF-IDF, this algo does two things. One, I think I have written it somewhere. Term frequency normalization. It normalizes the term frequencies along all the things. Next, length of document normalization. It's still, if you understand the intent, spelling doesn't matter. So let's see a formula, right? I'll try to copy this and paste it here. No, I'm not able to paste it. So let's see it here only, right? So I okay, I cannot minimize this. Okay, so if you see this formula, you have here IDF, which is inverse document frequency of QI. No, let me tell you what is QI and what is D, things like that. So basically, QI is ith query term, and what is it? So if query equal to Taj Mahal. Okay, so super. If query equal to Taj Mahal, then first query term is Taj and second query term is Mahal. So in similar way, QI is ith query term. D is document count. What else? Okay. N is nth query term, something like that. So D is document count. K1B. Okay, field length. Field length is length of current document, right? Yeah. So average field length, average of all documents, length of average of all documents. We'll see what is K1 and what is B. Do not don't think this is a very big formula and it's mathematically non-intuitional. Yeah, obviously this is mathematically non-intuitional because this formula is derived maybe based on many years of research that they did on multiple data sets like Wikipedia data and something like that. So you don't have to bother about this formula. What you have to bother about is what for a given data set, what are variables in this? So let's see, right? So for a given data set, for a query, inverse document frequency is constant because it keeps changing, but you cannot manually control it, right? For a data set, this will be constant for a data set and for a given query. This f of qi comma d, which is frequency that I forgot right here, f of qi comma d. Frequency of term qi in document d. Maybe this is not document count, this is document d, current document, curdoc, yes. Yeah, so let's give enter mark here. Yeah. So if you see for a given user query, for a given search query, and for a given data set, the ith query term will be constant. The frequency of ith query term in a particular document is a constant. All these things are constant. Only that varies is B and K1. And to pick B and K1 universally, which satisfies all types of data, is not possible because each, like, no, Elastic doesn't know what kind of data you are ingesting in their using their Elasticsearch. Like, they don't know, right? Because once you purchase Elastic instance, and depending on the GB or depending on the disk space that you request, will be charged based on that, and they don't have any idea on this, so they cannot select it for you. So basically, it's you have to who you have to select based on your data, and this is what K1 and B means. So for example, let's see this, right? IDF score. What is the formula for IDF score? I think this I have shown you in my previous video also. Again, this is also not a mathematical intuition formula. This might have proof, but obviously this is like research result. So yeah, even this is constant, right? Because frequency of QI is constant, and the document number of documents also is constant. So inverse document frequency will be constant for ith query term, for any query term. Now let's see what actually matters. Like, why does this um, like B and K1 that matters that much? Because if you see this the score, depending on this depending on this multiplication, your answer may vary, and your chunks that you retrieve from Elastic might be different. So we'll see three cases, right, that they have mentioned in their official blog. B equal to, let's take B equal to 0.5. K1 is 0. If K1 is 0, what happens to this formula? Uh, where is this formula? Yeah. If K1 is 0, right, this entire will be 0. Something plus 0 equal to something. Numerator will be 1. So numerator and denominator will cancel, and score equal to sum of ID, inverse document frequency of query terms. Correct, right? If you put K1 equal to 0 and does like this. So let's see one more case where both are 0. B equal to 0 and K1 equal to, doesn't matter. If, like, okay, I think it's a 10. So here I mean to say high. K1 is high. So if you see B equal to 0 and K1 equal to I, this is 0, and this will be 1. Frequency of, it will be, let's say if A equal to frequency of Qi and B equal to K1 plus 1, it will be um, but if you see, like, this will be always increasing. Like, if frequency is increasing, this is increasing, and you are producing this with 11, and if you are this, you are adding 10. So this will be always greater than 1, and if you are multiplying something will always greater than 1, this score will always increase. So since in order to increase this score value, you have to, if you keep increasing this frequency, the score will increase. So again, score is directly prop to term frequency. That's what f of qi comma d does. So if your b1 is 0, negligible is 0 or negligible is small, and if your k1 is high, it doesn't matter it doesn't matter whether how you implement it, and ultimately it's going to depend on a term frequency, how frequently the document occurs. And inverse document frequency of queries are already predefined. So not predefined. These are constants basically, and these also, if you see, these are like cannot guarantee because it's a logarithmic function. But yeah, if term frequency increases, this value decreases, this entire value, because something from constant plus 0.5 are subtracting this, and 1 plus decreasing value, uh, overall the IDF score will be decreasing, and yeah, so it will be directly proportional to like frequency of documents. So here what I am trying to say is, in both cases where either of k1 equal to 0 or b equal to 0, score is same as T of IDF. There is nothing, there is nothing special in this, right? Because we see, have clearly seen here, if we substitute 0.5 and 0 and 0 and 10 in this formula, you will realize that. And we don't know that, because the entire point of this is, um, you have to pay penalty, you have to give penalty for higher occurring terms, and you have to give penalty if your field length is more, right? If your field length is more, your denominator will become more, and your this for the particular query term, um, for the particular query term, the score decreases, the contribution of score decreases, because yeah, because that's what, like, otherwise, as I have told you, if field length is more, this is more accurate, there is a more chance that a particular query term will appear more. So yeah, this is a good point, right? There is a more chance that a word is to be likely appear more frequently if doc size is more. That is, that's what it we have seen, right? Because by increasing doc size, let's say for a doc d, the field length, the average field length, let's assume it's constant for every, this will be constant, because yeah, that's like this, that's average, right? So why you are dividing it, you are dividing this with field length to penalize the length. You are using doc length divided by average doc length to normalize the length of documents in your search engine. Like, it doesn't matter if you'll be hearing, or you might have this feel that our search results are bad because of the difference in length of the documents. No, that's not correct, because Elastic internally handles this by giving penalty for your documents. If you feel that your more length document is getting max score, that doesn't happen, because I'm penalizing here for this. If this is a constant, if this is a higher value, um, this is greater than 1, and it increases the overall summation of this denominator. That means it decreases the score, at least for this, for a single query term. So that's why here it comes the penalty of length and this. And similarly, b also, like, k1 also does the same. Like, k1 is for term frequency normalization. So it's again same thing. Like, if you want, we can see one example, a very good example in this series of BM25 part 1, how this official blog by Elasticsearch. I'll share it in the group chat. Yeah. Let's not name it as official. It's not good. So yeah. So yeah. So if you see, by default, okay, there is no okay. We can come to this point. There is no global rule or rule of thumb to pick B1 K1 because you see right how the things might change. Maybe imagine this: the mathematicians or the researchers would have gone like you might think that what is the range of B and K1 that they might have kept in order to come up with this formula and I cannot release this. Like, let's say, Elastic cannot release this BM25 saying that this is our best re-ranking function because they have to prove why why BM25 is better than this. And by doing vigorous experiments and very good research work, they have come with the default values, right? So when you don't specify anything while creating your index, so B is 0.5 and K1 is 1.2. Depending on your data and your observations, you can change the B and K1 value while creating the index itself. If you mention these two, B and K1, while creating the index, um, BM25 algorithms uses here you are seeing B and K1, right? Your B and K1 instead of 0.5 or 1.2 in the calculating scores. Maybe if you feel like term frequency in my case is more relevant. So term frequency, if a term is occurring more number of times in a document of much length, if you feel that's your answer and that's what is more your to your use case, you can do that. You can make your K1 higher because yeah, since K1 controls the term frequency normalization, if your K1 is higher, the more K1 the more K1 is higher, um, this score will be more because it is more aligned towards frequency. It's not normalizing it. It is not frequency normalization if K1 is high. K1 is 1.2 is the best frequency normalization that they have observed. Yeah, basically, if you have seen Lucene here, so Elasticsearch is built on top of Lucene, which is completely written in Java. By the way. Yeah, now if you see a very good example in their block 3, what to so if you see here, I have taken the formulas from here itself because I have read this BM25 from here only, and they have good example for this. Like, yeah, this is example how to create index with you want with your own B and K1 values, and yeah, they have created indices with different B and K1 values. If you see K is 0 here, which means directly proportional to term frequency. If you see B is 0, which might be meaning other thing. And if you see this is neither 0 not 5. Neither 0, none of them are 0. But you can see in this index how chunks are retrieved based on the data that they added here. This is a very good example. Give it a read. And yeah, I think this is like a story thing, a very wonderful, a very good guy has written a very, I don't know how to put it, like good engineer has written this blog. So this is a reader friendly blog. So yeah, and yeah, considerations for this is what I wanted to show. So yeah, and again, like if we are the most of the cases, 90% of the cases, these should work until unless you have more specific use cases for your data. So yeah, these are the different things that shows that Elastic is so powerful compared to other search engines, because it's not only searching for keywords. So what happens is, uh, when you search for Taj Mahal, right? You get docs which contains Taj and which contains Mahal. And based on this, you need to re-rank the documents and you need to return. But what if this is like our condition. So Elasticsearch internally breaks your user query with white space and treats each word as a query term. That's what it is doing, right? Taj is a different term and Mahal is a different one, and it re-ranks the documents which contains either of the words and also both of the words. It's a very good point. So re-ranks docs with words either of Taj or Mahal or both Taj and Mahal. Is a good one, right? Yeah, it's a good observation. Yeah, it's not observation, that's the fact of Elasticsearch. But yeah, but if you want phrase match, same thing happens with not only when okay breaks your user query with white space, not only white space, right? Maybe underscore, maybe hyphen. I don't know how, whether this is called hyphen or not, but still, yeah. So it treats this as a different terms and this. But if you want, if you have something like ID, say 121 underscore 1ms3e. So if you want to search this, you don't want to be not to be 121 and 1ms 3e. You want it like a entire word, right? So what you can do is, instead of doing normal search, you can do match phrase, where you will search the document which contains this entire thing, 121 1ms 3e. That's what they mean here by phrase matches. And making use of synonyms, like yeah, like if you search for a, if you are searching for a word, maybe yeah, like there is a word and you are searching with its synonym, but still, since the your query word is a synonym of the word that present in the text, you want that document to be picked up. In that case, you should have a synonym matching. That's otherwise it's not possible to search. Adding fuzziness. So fuzziness in the sense, so for a word called as palak paneer, search query might be Pakal Paneer. So, but if you see documents, there is no word something called as Pakal, but user intention is to find Palak, and there is a fuzzy between these two. These two are fuzzy words, but still you should return results for Palak Paneer. Yeah, phonetic matching, like uh, okay, let me type this as um, what's the name for this search? Yeah, all these searches again, I will explore and do streams on this, because yeah, like search is my interest. So phonetic search, if you ask, Nobody knows the, I think not nobody, but many people don't know the correct exact spelling of a word. Maybe Schwarzenegger, or some people can write it as Schwarzenegger. Like nobody can do it wrong, right? Nobody can do it right because it's a very difficult word to pronounce. But if you do search on this and if you try to find, you'll get a zero chunks because this doesn't match. This doesn't match with the original name of Schwarzenegger. So, but still, you can match it to a sound, Schwarzenegger, and maybe something there is something which phonetically represents these two words because sounding is same. Phonetic means sounding same, and the actual Schwarzenegger also sound is same. But I think based on what they're matching, and I don't know how these are converted into that phonetic mappings. So yeah, that's the phonetic search they maintain. So okay, interesting. So yeah, so that's why Elasticsearch is so robust and it's mostly used. And yeah, like these are different uh, experiments. Like as I told you, this B and K1 value is like experimentation. Nobody can typically guarantee you, but they have some suggestions how to range your K1. Sorry, why is it okay? There are some suggestions how to range this K1 and how to range this B for you, like maybe. And you can read this exam, you can read this paragraph, and you can ask, you can see why does it K1 and B matter that much to the best BM25 algorithm. So let's read this. Okay, what does K1 mean? When do we think the term is likely to be saturated? Okay, let's make note of this because these are very rare and important words. When do we think when do we think a term is likely to be saturated? For a very long documents like books, especially fictional multi-topic books, it's very likely to have a lot of different terms several times in a work, even when the term isn't highly relevant to the work as whole. For example, I or ice can appear hundreds of times in a fictional book, even when ice are not one of the primary subjects of the book. Yeah, like what is trying to say is it doesn't matter. So what is trying to say is more frequent word in a long document may or may not be important. It's not telling it's not important, may or may not be. We have to penalize, we have to give penalty or score according to the length of the document and frequency of the term, right? So yeah, you may not want terms to be saturated as quickly as in this situation. So there are some suggestions. When the text is more longer and more diverse, you can have okay. K1 should be generally larger numbers, okay. Yeah. Let's see the second suggestion. It's been suggested at a lower side. It's very unlikely that collection of short news articles would have eyes dozens to 100 times without being highly rated to eyes as a subject. Yeah, again, this is like a fact. Like that's a fact. Like yeah, that's a fact. I cannot explain how why it's a fact. Yeah. So let's see B. What does they do? So this is for K1, right? So let's see for B. have some water. There is very less water. Yeah. Still. So for B, we should ask, when do we think a document is likely to be very long, and when should that hinder its relevant to a term? So yeah, let's again paste this somewhere. These things doesn't at least doesn't enter my brain in one read. So it will start making sense when you see it or read it more number of times. And yeah, documents which are highly specific, like engineering specification patents, are lengthy in order to be more specific about a subject. Their length is unlikely to be determined to the relevance, and maybe B is more appropriate to be lower. On the opposite side, document which touch on several different topics in a broad way often benefit by choosing larger B, so that irrelevant topics to users include spam, like, or penalized. Again, B is for term frequency. No, B is for, I think, length penalization. Yeah, length normalization. Yeah, like, yeah, that's it. This is one of the nothing, like, if you see, if you are if this is a search query and you want to see what does doc for, why does it give doc for this score, it explains everything. Elastic gives um everything like this. Yeah, you can field length, average field length. If you see, we have seen these terms. So yeah, it's a very beautiful, it's a very super, like, I don't know how to describe, but this is one of the greatest invention. Like, Elasticsearch is one of the greatest invention. Yeah, again, like, they be Elastic itself told BM25 is not only the scoring algorithm. There are many uh, scoring algorithms. Like, maybe, I don't know what is this from. Let's see what is this. Okay, Wikipedia pages are very hard to understand. So page rank, again, more harder to understand. So yeah, like, you can read some of the paper, but yeah, I think till here you can, it's good. Like, yeah, maybe if you know well, you can choose your K1 and B value, so that you can score your documents according to what matters for the users to whom you are developing this, because data is yours. Yeah, this is one of the things that I wanted to share, and I was been exploring this for quite some time. With this, we covered three things in search engines. Maybe I'll come up here. It's not initial thoughts. Let's make it as cover topics. First thing is basic search engine, inverted index for mapping search super fast, TF-IDF, basic B ranking algorithms, BM25, advanced re-ranking algorithm. Currently, Elastic uses eternally. Yeah, so coming, like, upcoming, what will be upcoming in this series? Maybe in fuzzy search, because user can search anything, right? Phonetic search, um, semantic search. I'll come from top to the bottom to up, because Exploring on semantic search might help me at my regular work also, because it's some kind of related to semantic search. So yeah, this is on this series, and maybe you can expect three more videos in this, and this is a third video. And you can, like, this is like six video series with practical example. And if you have seen, I have shown a code in my last two things, explaining how to make it, how to create one in real life. But since it's a heavy mathematical lifting, I don't need any code to show, because what's the point if I even write a code for this? Doesn't matter, right? Elastic already have this. Yeah, that's it for the stream thing. But I still wonder what is, okay, what is 25 mean in BM25 algorithm? Even I don't know. Maybe I don't know. BM is best match. I know. Version number. Okay, best matching 25. Another family ranking information retrieval system. Okay, several variations. Version demonstrate best performance. Look at the versioning that they tried to get to the perfect formula, like this formula. Yeah, doesn't refer to value formula itself, nor it refers to 25 iterations. Okay, yeah, I think we know this, like K1 and B, we just have seen. So it's good. We are good. This is a three-part blog. Please, if you're interested around re-ranking and stuff, please read it, because it's very interesting, like reading friendly. The person who written this is might be so cool in life. That tells that. Yeah, that's it for this stream. And let me drop a like for him. How to drop? Okay, one like for Akash, my first viewer. Yeah, ending my ending my stream. Thank you.